Welcome all. Today we are going to see the travel salesman problem and missionaries and then cannibals problem. It should be like coming under the toy problems. Before going to see the problem, so to now we are going to see the problem types. So how we are going to handle the problems in the such a way. Okay, so we are having the four kind of the problem statements. We are going to analyze the variety of problem statement like the four level. So this is one of the important problem solving method in the AI. So before going to solve the problem, so already we have discussed the first domain knowledge we have to observe and what all the steps flow and then state space, everything we have to just understand more for the thing. And before that, this is also the very important thing for analyzing the additional information for solving our problem statements. So first we have to understand the different type of the problem in such a way that, so first one, the deterministic or observable, that is a single state, and then non-observable multi-state, and then non-deterministic or partial observable, and then unknown state space. So these are all the four kind of variety of problem solving in the statements. So here the four level each, it will be just based on the how much of the information in the particular problem and then agent. So we can just solve with the particular environment. Okay, so everything we have to understand. So first we are going to see that the first thing like the deterministic and then observable. In before that we are going to see the different that is a categories of the types of the problem and the nature of the problem in the short way. So first the deterministic and then observable. So this is only observe like the single state problem, and then the goal state as it should be the reachable in the one single action only, it will be just demonstrator. Okay, so the next thing is non-observable. We can just access with the multi-state level, that is a multi actions we are going to analyze. So each state we can just count for the transition and then observe the thing and then maintain the knowledge base for the another state. So then only we can easy to reach out our goal. The next one, non-deterministic or partially observable. So this is one of the like as look like as a non-observable thing only. Like what not, it should be like taking the effect of action not clear, the every new state and then new information added. So each and every single state, it will be just adding to the new information in simultaneously. So we have to just observe and then just define with the domain knowledge, and then we can just start with the like what now, so we can process with our final outcome. So everything and then every action, it could be just added into the new thing. So then only the operator act on as the state level. Okay, so this is the thing happening for the non-deterministic or partially observable. So the thing is what now, each state it will be just take over like the new added information in into the solving our problem statement. The next one, unknown state space. So this is one of the exploration problem. The exploration problem, it will be observed with the state and the impact of the actions are not known. So here the state and then impact of the action, it will be just roll out to the every statement. So each and every statement we have to just make with the proper action and then proper rule for recovering our or retaking our outcome. Okay, so this is one of the nature of the problem definition for the thing. So here the both the states and then the effect of action are initially unknown, but the agent must explore the information. That is the main thing for that, and then we can apply for the state space of the problem. Okay, so we can just adopt with the all configuration setup for the particular problem, and then we can easy to solve with the problem, and then we will achieve the good state of the goal. So first one, so we are going to see the deterministic single state of problem. The main the deterministic problem, so already we have just discussed the short nosed in the level. So exact action it should be required. Okay, so that is called the deterministic. So one where every action leads to the one predictable outcome. So in generally, so we can just predictable outcome it will be focusing. The agent known the complete the statement environment, and it can be just to solve the solutions conditions and then some certain level also. There is no certain involved means the common the thing like what now some actions it should be added. Okay, so the deterministic means what? So we are having the then proper rule, and the proper rule it will be maintaining the all those possible way we will just get it the good outcome over here. Okay, so in the each state of the like the environment it will be fully observable, like top to bottom wise it will be updating and then analyzing and then understand the domains verification, and then after only we can apply with the thing. Okay, so that is one of the very very important thing. Maybe sometime it will be just a uncertainty level means, so we cannot do anything. Okay, the problem it will be just leads to the not solving our not getting and not solving our good problem and then good solution. Okay, so we are not getting the good solution. So that is the thing. Maybe the observed thing and then observed thing it will be just maintaining the certain level of the condition we will achieve our goal state. This deterministic and then observable state, so we are having the good example for chessboard. Okay, the board is fully observable, so each and every rows and then column wise everything it will be just observable, and then we will get the like we will get and then apply for the correct rule pattern, like we want to check the rules for the each and every rows and then column, and then finally we will get the good outcome. So this is called as a deterministic and then observable single state. And then the next one is non-observable state. So non-observable state it will be just not only the opposite for the deterministic, it will be deterministic state only, but what now it will be required the multiple state of actions is needed. Okay, for getting the final outcome. So for example, so we need to solve the particular environment, we have to just observe the all state, but the all state is not connected with the clear cut of knowledge. Okay, so any information it should be there. Okay, we have to analyze the each state of information, and then we will get the after only we will get the some solution. So that solution it will be incorporate to the state space level. Okay, all possible solution we have to just adopt into that. Okay, the solution may or may not be reached. Okay, so the mainly definitely it will be reached the solution, but sometimes it will not reacting to the good level of the solution. Okay, so that is the thing. And then always it will be connected to the multi-state level of the multi-state action and multi-state level of the problem. Okay, so for example, the non-observable condition, the vacuum cleaner is the one of the good example for here. Here there is no sensor, maybe we have to observe with the no sensor means it cannot able to suck the particular dirt, and then the once the dirt is not sucked and then the machine only roll out means, so left and right it will be just going on that now, so we cannot get the good level of the floor cleaning. Okay, so we cannot able to get it the clear level of the floor cleaning. Am I correct? So this is the thing is happening, only the sensor is on, and then the sensor is like the process is on, and then the sensor is observable means, so definitely it will be just suck the dirt in the particular place, and then it will be just towards move to the left side and then right side where it is the dirt is present in the particular way. So everything it will be clear. Okay, so the main thing is what now, the sensor is on now, it will be just react to the all over the rules, whatever the rules, and then it will be just applicable into the vacuum, so it will be working. The sensor is that is the not concern and the on level means, so it does not take with the all kind of the rules. Okay, so it will be not able to put on the just and then suck with the dirty, and then it cannot just moving and right operation only it will be happening. Okay, so this is the drawback is happening for the non-observable state. So at that time we can make with the new method, what is the strategy we need to follow, what is the action we could just follow into that, and then we can solve with the problem case. And then the next one is the non-deterministic, like the partial observable. Okay, so partial observable, so we can, it will be just 80% of result, but the not the 20% is the does not under with the good level of the outcome. Okay, but some of the percentage partial level we will get it. Okay, so for example, each action is not clear, but the new information, whenever we will get the new information in the particular thing, we can adopt, and then we can just processing with the non-deterministic level of the problem. Okay, for example, the environment, the driving, the environment is partially observable because what's around corner is not known. Okay, but the car is running, but we could not able to find the what is the thing is happening in the surrounding level. So until that we cannot able to give the good level of the result. So meanwhile time the car is driving, okay, or we have drive the car, okay, so the going the car and on the particular time, so we cannot able to observe the what the thing is happening in the nearest place and then surrounding place, etc. So we have to just observe into the certain conditions. Okay, we have to just analyze with the what is the thing is happening, and then how much of the speed we are going, and then the what is the status level of the signal. Okay, so who are all just crossing, so peoples are waiting for the crossing, so everything we have to analyze. So at present of that level we have to just make with the new information. Okay, so that particular information it should be just connected with our final outcome and then good knowledge representation also. So based upon the knowledge representation it will be just observe with our internal level, and then we can just make with the good level of the outcome. Okay, so this is the thing is happening for the third one, non-observable state. So next we can continue for the fourth level of unknown state space problem. So this is the unknown state space problem. This is one of the multiple state of the problem solving method, and this is one of the important thing for the unknown level of the problem solving. So we can observe with the different kind of the state space method, but in the particular state space method we can solve with the some exploration of the unknown level. So that is the thing is happening. So we have to just observe the all kind of the variety of information, but we cannot just come with the like the known information. Okay, so unknown information we can observe, and then we will sort out the final level of the thing. So the agent cannot fully observe the environment, that is the main thing. So because of it lack of the complete information, so main the rule and then complete information it doesn't take over in the particular agent. It must consider the multiple possible state before making the decision. That is one of the important thing. And then for example the vacuum cleaner without sensor they cannot detect the dirty. So that is the main thing. So but our target is what we have to the vacuum cleaner has to just clear with the every dirty. That is the target. So it must clean every location regarding and then regardless and then of the whether the dirt is present. Okay, so the sensor we can just on means the automatically the process it will be just go on into that. So unknown information only as a we have to just observe the like the complete information we need. So without the complete information we cannot able to guide with the proper movement of process. Okay, so for example the online search involving the act without the complete knowledge of the next state or scheduling without the map. Okay, so this is the very good example because we need the some proper knowledge about the information. Okay, so where we want to go and what is the thing we need, so everything we want to search in the Google. Okay, so then only we can get the clear cut of the information. Otherwise something we can just give and then we have just expecting the relevant information means definitely we cannot able to do for the thing. So this is the main case for the non-observable problem state. Okay, so the non-observable problem state means we have to just know the proper way. Na? Definitely we will get it. Sometimes we are not getting the unknown information and then unknown level, and then the lack of completion of the problem solving means definitely we cannot able to get it. So this is the thing. And then next we are going to move into the travel salesman problem. Before going to the travel salesman problem, so until now so we have discussed the four level of the process. Okay, so that the four level of the process of outcome is a very good level of the outcome, because every information we will get now definitely we will get the good outcome level. Maybe the partial information we will get means we have to just work out the more information for clear cut of information, then only with our process and then our problem it's going to solve into the proper level. And then maybe so the unknown information we don't know the any information and then any process, but it should be expecting the good level of the outcome means, so sometime it will be lagging. So that is the main thing is happening. And then so we need the some prior knowledge also. Whenever we can go with the uncertainty and then deterministic and then non-deterministic problem, we need the some knowledge for clearing the all information. Okay, then only we will reach out the good outcome. So next we are going to see the real world, that is a toy problem for the traveling salesman problem. So this is one of the real world problem in the AI method. Okay, so the deliver person who must visit the several cities exactly one and return to the starting city, and the main objective is what not to find the shortest possible route with minimizing the travel distance or cost. So this is purely dependent to the cost method. Okay, so the particular person wherever he wants to go means, okay, definitely wants to go, but the shortest path with the minimum of value is very very important. So that's the thing only, it will be just roll on into that. So this is the thing, important thing. So imagine you are a delivery person trying to visit the multiple cities. Your goal is minimizing the total distance traveled while visiting the each city exactly once. So that also very very important constraint. So we need to just go visit that particular city as the only one time, not for the many time. Okay, so only one time as the one of the constraints over here. And returning to the starting point, how would you decide the order for the visit for making our problem? Okay, the constraints is what? So we need to analyze the shortest path with the shortest value. Okay, and then optimal value also we need to analyze. That is the first rule. And the second rule is what? Actually we want to just visit the all cities. Okay, so whatever the present in the particular problem we have to visit, and only one time, not for the more than one time. So only one time has to go. And then the second thing is what now, when wherever we can start as the in starting point, at the same point we have to reach out. Okay, so we have to visit the all cities and then come back to the starting point. This is the three important conditions for solving our problem statement. Okay, so this is one of the main definition. So whatever the problem like the TSP problem, this is one of the main definition to find the cheapest tour of the select number of cities with the following restrictions. You must visit the each city only once, and then you must return to the original starting point, and we can just make over the cheapest cost. So these three rules as we have just solved with our travel salesman problem. So here we are having the two kind of the travel salesman problem over here. Okay, so the first problem, the constraints is what now? So A as the starting points we have to just fix it. That is a point, it will be travel into the next level of the positions. Okay, so starting point wherever it will be just fixed, again we have to come into the A position only. That is the rule. Okay, so and then we have to analyze the each and every optimal value. Okay, wherever the starting position, ending position is there, we have to just visit with the all over values, and then node also it should be there. Okay, so this is the thing is happening over there. First the first node is here. Okay, so this is the starting point. Okay, A, so A it will be just going to the B, and then B it should be just connected to the C, and then C it should be just visited to the D, and then D it will be again goes to the A. Okay, so this is the first statement of visiting our city. Okay, the another possible way is what? Same, we can take like the A as the starting point. The next one B, A to B it should be just visited, and then B to D, and then D to C, and C to A. This is one of the another possible way of the condition. The third condition is what? Actually A to C, C to B, B to D, and then D to A. This is one of the another possible connection for the A to C. A to C connections. The next one, same thing, A to C, C to D, D to B, and then B to A. Okay, this is one of the another possible connection for the mapping of A and C. Okay, so the next one is what? A to D. Okay, so what are the two mode of connections over there? A to D, and then D to C, and then C to B, and then B to A. This is one of the another possible way of this A to D combination. Okay, and then the next one, A to D combination. So A to D, and then D to B, and then B to C, and C to A. This is one of the another combination. Okay, so here we want to just apply for the what all the values over there. Now we can just apply for the value, like the first row of the value, like the cost is what, actually the A to B as the cost is 2, and then B to C, and then the cost is 8, and then C to D the cost is 1, and then D to A the cost is what, D to A. Okay, D to A the cost is 7. So total we are having 2 plus 8 plus 1 plus 7 equal to 18. The next possible way is A to B the cost is 2, and then B to D the cost is 3, and then D to C the cost is 1, and then C to A the cost is 5. The total cost is 2 plus 3 plus 1 plus 5, the equal to 11. Okay, and then the next one, the possible way is A to C. Okay, so A to C the cost is 5, and then C to B the cost is 8, and then B to D the cost is 3. Okay, and then D to A the cost is 7. So total 5 plus 8 plus 3 plus 7 equal to 23. And then the next one, possible way, A to C compo. So A to C the cost is 5, and then C to D the cost is 1, and then the cost is 1, and then the D to B the cost is 3, and then again the B to A the cost is 2. The cost, how much of the cost? 5 plus 1 plus 3 plus 2 equal to 11. The next one, the compo is A to D compo. A to D the cost is 7, and then the D to C the cost is 1, and then C to B the cost is 8, and then B to A. Okay, B to A the cost is 2. The total cost is 7 plus 1 plus 8 plus 2 equal to 18. And the next compo is A to D. So A to D as the 7, and then D to C we can just take with the value of 1, and then followed by C to D, sorry, C to B. So C to B we can take with the value of path cost is 8, and then B to A. So B to A we can going to take like the 2 as a path cost. Totally 7 plus 1 plus 8 plus 2 equal to 18. And next one, the compo, another compo is the combination of A to D. So here the A to D as the path cost is 7, and then D to B as the path cost is 3, and then simultaneously the B to C as the path cost is 8, and then followed by the C to A. So we are having the path cost of 5. So total 7 plus 3 plus 8 plus 5 equal to 23. So these are all the path cost of the value. It can be represented in the connection of the directions for the each level. Okay, so now we want to check which is the minimal value of the path cost. Okay, so here we got the minimum value of the combination of A to B, and then the combination of A to C. So we can achieve the two direction of the path minimum level of the path cost. So the 11 11, so A to B, B to D, and then D to C, and then C to A, and A to C and D to B, and then B to A as the one of the another direction of the path cost. So we can apply for the rules. For the 3 rules we can just apply, already applied. So what are the rules? We need to just find with the minimum of the path cost. Okay, so that the thing also satisfied, and whenever the starting point is started, same point as we have to just ended into that. Okay, so same A as the starting point is that, so same A as the starting point we have visited. Okay, so and then the third constraint is what? Now we have to visit only one time in the each city. So one time only we have visited. The target is actually we have achieved, and then minimum path, past path also we have determined. Okay, so the next problem is, this is the problem 1 to 2 to do as the TSP. Okay, so now the before problem we can just represent like the ABC like that. Here we can represent as a numbering. Okay, so numbering with the path cost. So the same thing we have to apply for the 3 rule here. Okay, so what the thing first, the first as the 1 as the starting point here. So 1 to 2, and then 2 to 3. Okay, and then the 3 to, and then 4, and then 4 to 1. This is one of the compo. The next one 1 to 2, and then 2 to 4, and then 4 to 3, and then 3 to 1 as the one of the compo. The next compo is 1 to 3. So 1 to 3, and then 3 to 2. Okay, and then the 2 to 4, and then 4 to 1 as a one compo, and 1 to 3, and then 3 to 4, and then 4 to 2, and then 2 to 1 as a one of the compo. Okay, the next one 1 to 4, and then 4 to 2, and then 2 to 3, and then 3 to 1 as the one of the compo, and then 1 to 4, and then 4 to actually what 4 to 3. Okay, 4 to 3, and then 3 to 2. Okay, 2 and 2 to 1 as the one of the compo. Okay, so all nodes we have visited. Okay, all the cities we have visited only one time, and where is the starting point? Same starting point also we have just end up with the each and every travels. Okay, so the first one now we are going to apply for the values over there here. Okay, so 1 to 2, what is the value? 2, and then 2 to 3 we are having the 5, and then 3 to 4 we are having 3 to 4 we are having the 3, and then 4 to 1 we are having the 1. So what is the cost? 2 plus 5 plus 3 plus 1 equal to 11. And next one 1 to 1, 1 to 2, same compo, same compo of the 1 to 2 another way, like the 1 to 2 and then as the 2, and then 2 to 4 as the 4, and then 4 to 3 as the 3, and then 3 to 1 as the 2. So we are having the 2 plus 4 plus 3 plus 2 equal to 11. Okay, the next compo is 1 to 3. So 1 to 3, so we are having the value for 2, and then 3 to 2 as the 3, and then 2 to 4 as the 4, and then 4 to 1 as the 2. Okay, so what is the value? 2 plus 3 plus 4 plus 2 equal to 11. So these are all the level. So another compo is, and the next compo is 1 to 3, and then 1 to 3 as we can consider as a 2, and then 3 to 4 as the 3, and then 4 to 2 as the 4, and then 2 to 1 as the 2. So we got the 11 as the path cast, and then the next compo is 1 to 4. So 1 to 4 as the 1 as the cast, and then 4 to 2 as the 4, and then 2 to 3 as the 5, and then 3 to 1 as the 2 as the path cast. The another compo for the same thing 1 to 4, actually the 4 the 1, and then 4 to 3 as we will get the 3, and then 3 to 2 5, and then 2 to 1 as the 5. So total cast is these also the direction of the cast, but all are getting like the same 11 12 as the cast only. So we cannot able to decide so this direction, but we can just consider for the direction is the multitask level 1 2 3 4 and then 5. This is the minimum cast of the TSP. Okay, so that we can just connected with the three rules. So we have to just define with the final optimal value. So we got the optimal value for 11 only as a minimum value, and then wherever we can start with the node, and then same thing only we can in the node also we have connected. And the third rule is what now, each and every city we have to visit only one time. Okay, so this is the constraints. The next one as the another problem for mercenaries and then cannibals problem. So the mercenaries and then cannibals, so we have to just catch with the cannibals into the final level. So this is the constraint. So what are the constraints they have given means, so in this problem we are having the 3 missionaries and then 3 cannibals which to cross over the river. So they have the small boat, okay, that will carry up 2 people. Okay, so everyone can navigate the boat, and at the final time of the cannibals and then outnumber the missionaries on either bank of the river, they will eat the missionary. Okay, that is the main concept. So the more than the cannibals now, there is no problem. Less than the cannibals of the missionary means the missionary will be eaten. Okay, for the cannibal. So that is the main constraint. Okay, so we have the more cannibals compared to the missionaries means, okay, there is no problem. So otherwise it having the less missionaries which compared to the more missionaries which compared to the cannibals means, definitely the cannibal the missionaries will be eat the cannibal. Okay, that is the main constraints. And next one, how the everyone get the actors and then the across the river means, so first one we can just go with the constraints of the rule here. Okay, so here as the one of the main constraints of the problem. So what is the problem is happening means, so this is the problem of the thing. Okay, so here the missionaries is that the cannibal problem in the one stone. The three missionaries and then cannibals are on the side of the river. Okay, and then there are the boat and then can hold one or two people. We need to find the way to get everyone to other side of the river without ever the leaving of the groups. So missionaries in one place and outnumbered by the cannibal in the place. Maximum two objects of the missionaries and then cannibal can travel other side. Minimum one has to be there in the boat for the boat come to the back. So that is the constraint. So okay, wow. So now we can just go with the these also the possible state. So we have to just apply for the 8 possible things. So the condition rule is what? The missionaries, the any one number have to just travel with the boat. That is the first condition. The second condition is the more than the missionaries means there is no problem. The less than the missionaries means my missionaries will be eat the cannibal. That is the 3 constraint. Okay, that the thing we want to check it. Okay, so the first statement, first rule is what now? Starting is 0 comma missionaries. Okay, one missionary sailing the boat from the left to right, any portion, left to right or right to left. What is the game playing is that? So based upon the thing we can move it. The second state is what? Missionary comma 0, one missionary sailing on the boat from the right to left. Okay, no issues. And then third one, missionary and then missionary, two missionaries sailing from the left to right, two missionaries sailing from the right to right. Okay, no issues. The CC, two cannibals sailing from the left to right, no problem. We can just make with the two cannibal and then two missionaries, there is no problem. The constraints is main important thing is what? We are having the less missionary means less cannibals means definitely the missionaries will be eating to the cannibal. That is the main thing. And OC, there is a one cannibal sailing the boat with the left to right, no problem. The C comma O, one cannibal move to the right to left, no issues. And then M comma C, one missionary and then one cannibal sailing the boat left to right, no problem. And then C comma M, one missionaries and then one cannibal sailing to the boat from the right to left, there is no problem. Maybe in this 7 and 8 case, so we are having the two missionaries and then one cannibal means definitely the missionary going to eat the cannibal. Okay, that is the constraint. So this is the boat representation. So we are having the boat representation over there. So we can just take with the this is the cannibal and then missionary. Okay, so the constraints is what? Actually the left to right, right to left, everything it will be movable only, but any one of the missionaries and then cannibal must be travel into the left or right and right to left to the process. And then the number of moves also it should be considered. Okay, so we are having the 8 mover. And one more thing is what now? The majority of the cannibals means there is no problem. And the same time, so we are having the less than of the cannibals means the missionaries definitely it's going to eat. So that is the rule number. Okay, so this is the process flow for the entire problem. Okay, so first one, so please look at here. First one, this is the boat. Okay, this is the anyone the we can consider as here. This is the cannibal, this is the blue as the missionaries, and this symbol is like what now? The marine navigation, and then this is as a boat. Okay, so first one, the two cannibals is traveling here. So cannibals is left out, and then one cannibal is moving, and then here the just pick up the cannibal over there, and then just left out, and then pick up the cannibal, and then just move to the next level, and then come to the next level for the another cannibals, and then just left out the two cannibals over there. The equal strength is over, and then next we can just take out like what now in the missionaries, it will be pick up into that, and then just drop out like the one missionary and then one cannibal. There is no problem because equal strength only here, and travel to the next position, and here also one there is no problem, and travel with the next position of the two missionaries, and here it will be coming, and then take out the just take out the like the one cannibal is coming. Okay, and then just move to the here. Okay, and then next move to the cannibal for the one another pickup in the left side, and then it will be just come to the here. So here the constraint is what? We can achieve the 3 as the equal strength of the cannibals and then missionary. So in the left side or right side, the three cannibals and then missionaries are one side. So our goal is what now? We have to just pick up, and then we can cross with the river, and then we can just send to the 3 members. Okay, the constraints is what? More than the missileries means more than the carry balls is maintaining for the each move means there is no problem. Okay, maybe the less than of the carry ball compared to the missileries means definitely the missileries is going to eat. Okay, so this is the main constraints for the missionaries and then cannibal problem. This is one of the important problem. The main objective is what? We can just move with the and then go with the safely transport for the 3 missionaries and then 3 cannibals across the river. It will be just across with the some certain condition, whatever we have discussed, that certain conditions with the state space search method, and then we will get the sort out the problem. This is the main thing. So based upon these things, so we can just make with the good level of the reality and then good level of the thinking, we can just apply for the these kind of the rules. And the game link also we have just text in the game link, so that also we can just easy to play, and then in the during the class time, okay, we can just make with the as a real time classroom activity. So just send this link to the students, and then they will just play for the thing, they will understand the as the real time knowledge also. And this is one of the important things. So now today's discussion, we have discussed the travel salesman problem and then missionaries and then cannibal. So we have just roll out the important real world optimization problem, everything, and then we can apply for the state point search method also for uploading, and then for making with the other all possible solutions also. So based upon the thing, we can just derive with the all kind of the toy problems, etc. Okay, so thank you for watching.